Okay, so in this first example for section 3.2, we are going to look at our empirical rule. We actually looked at this question and did a little bit with this in the last section, so now we're going to kind of revisit that example and expand on what we looked at in the previous section when we were talking about our smog levels. So data on smog levels in a sample of cities was collected, and the distribution was found to be roughly symmetric and unimodal. The mean particulate level for the samples was 10.7 micrograms per cubic meter, with a standard deviation of 2.6 micrograms per cubic meter. Again, we're looking at an example that we saw in section 3.1. All right, now we're asked to fill in kind of three different lines here. We're asked to find our boundaries for 68% of the cities, 95%, and 99.7%. So what we're going to do is we're going to use our standard deviation to figure these out. All right, so our center part is always going to be our mean. So 68% of the cities, we're going to have smog levels within one standard deviation of our mean. So our mean is 10.7, right? And then we're going to subtract our 2.6. We get 8.1, and then we're going to take our 10.7. We're going to add 2.6 to go one standard deviation in the other direction to get 13.3. So about 68%, right, is going to be between 8.1 and 13.3. Right, so what I'm going to do here is just on a sheet of scratch paper, I have a little curve sketched out that looks like our pictures. Right, so if we look at this little curve, what that means is our mean here is that middle value of that 10.7, right, and then that 8.1 and 13.3 are what we just found going in both directions. So as you're working through the problems in this section, if it's going to be beneficial to you, I strongly suggest that you take the time to draw out a little sketch. And we'll come back to this as we continue to go through this example. All right, about 95% of the cities are going to have smog levels in between, and we need to find these values. So one thing we can do, we can take our values that we had in this previous example and subtract and add them. So we're going to take that 8.1, which is our lower value. Since we subtracted to get the 8.1, we are going to subtract again. So we're going to subtract 2.6 again. We get 5.5. Then we're going to take our 13.3 that we got by adding. So we're going to add 2.6 to that one, and we get 15.9. So about 95% are going to be between 5.5 and 15.9 micrograms per cubic meter. So going back to our little picture here, that means that as we go out, we're going to have 5.5 as our label here, and we have 15.9 as our label here. Right. There is an alternate way that we could have figured this out. So I will just take a quick second to mention this. If you go from your original mean, we're going to subtract 2 times our standard deviation, and we're going to add 2 times our standard deviation, which gives us the same values of 5.5 and 15.9. So it just kind of depends on your personal preference. I think most people generally, as we're going through, especially if you're labeling a picture, we tend to just keep doing the addition and subtraction. It makes it a little bit easier, a little bit more straightforward. All right, then to finish this example up, almost all, 99.7% of the cities will have smog levels in between. All right, so we're going to take these two values that we saw here and subtract and add again. So 5.5 minus 2.6 gives us 2.9. And then we ended with 15.9 plus 2.6 gives us 18.5. All right, so we have 2.9 and 18.5 micrograms per cubic meter. Looking at our picture then, we'd have a 2.9 here and an 18.5 over here. Remember, as we're going through, again, we have 68% in the middle, 95% as we go out, and then 99.7% as we go all the way out to the edges. And remember, anything more than 2 standard deviations, so anything in this little tail here or that little tail here, would then be considered unusual. Right? To find these values, we can also calculate these our alternate way, and we're going to take 10.7 plus and minus 3 times. So minus 3 times 2.6 is 5.5. 10.7 plus 3 times 2.6 is 18.5. Oh, excuse me, not 5.5. That first one should be 2.9. Looking at the wrong one. There. Right, so however we do our calculations, right, everything should match up nicely. Again, and what we see here matches up nicely with our little diagram. And sometimes, even if you don't draw out the whole curve, just drawing yourself a little number line makes it a nice, quick, easy way to get through and work through these problems.